last of the formulas that we have for this unit are called the double angle identities. That if you double an angle inside, you can't just double the other side. Okay, so the following is not true. If sine of 2 theta equals 1/3, this is not true that sine of theta equals 1/6. You can't just take a 2 out of the middle of a function and do something. Okay? So what do we do when we have a 2 theta? Well, we have these new formulas. The only thing you can do with the sine of 2 theta is change it to 2 sine theta cos theta. And if you see a 2 sine theta cos theta, you can change it to a sine 2 theta. There's a formula for tan 2 theta, and then there are three different formulas for cos 2 theta. And the reason they're all exactly the same, meaning they mean the same thing, they're just easy to derive one from the other. So for example, and this is, you can see this in your notes on the top of page, at the bottom of page 653. If I started with cos of 2 theta is equal to cos squared theta minus sine squared theta, I could replace the sine squared theta with 1 minus cos squared theta. And if I did that and combined my like terms, I would get this version. Similarly, if I start with this and replace the cos squared theta with 1 minus sine squared theta and combine my like terms, I would get the orange version. So you have the green version that has cosine and sine. You have the purple version that just has cosine, and you have the orange version that just has sine. And whenever you have a cos 2 theta, usually one of the three is a little bit nicer than the other two. So we're going to see that today.
When you combine like terms, you get
Because if I move this away, there's brackets there, and that would get negative, would get distributed. You just couldn't see it because I had this over the brackets. Does that make sense? Yes. Now technically, this formula, for example, the cos 2 theta one, if you technically want to see where that formula comes from, you can use your alpha plus beta formula. If you change 2 theta to theta plus theta, then you have a sum and difference formula, where the alpha is theta and the beta is theta. And the formula for this is cos alpha cos beta minus sine alpha sine beta, and you get the double angle formula really quickly from the sum and difference formula. That's where it comes from. We never proved where the sum and difference formulas came from in class. But the double angle ones are just special cases of sum and difference, where you add theta plus theta to get 2 theta. And then you could use our first formulas to figure that out. In AP Calculus next year, the double angle formulas get used a lot more than the sum and difference. So these come up more often in AP Calculus. So let's look at example. And the start of example 1 should sound like the start of a question you had in chapter 6 and at the beginning of chapter 7. Given angle theta in standard position with terminal arm in quadrant 4 and cos of theta equals 2/5, so many questions start this way. And every time you get a question that starts this way, it makes sense to draw your 4 quadrants. It's in quadrant 4. Draw it in quadrant 4. Back to your nearest x-axis. Since you know cos of theta, you can label adjacent over hypotenuse. This would be your reference angle. A squared plus B squared equals C squared will give you square root of 21 for the other side. Then if I want to find sine of 2 theta, I don't know theta. It's a non-calculator question. There's no way I can figure out theta, because this isn't on my unit circle. The only thing I can do with sine 2 theta is look at my identity, my double angle identity, and change it to sine theta cos theta. And from my triangle, I know what sine of theta is. Sine of theta is opposite over hypotenuse. Negative because it's in quadrant 4. I'll get negative root 21 over 5. I was given that cos of theta was 2/5. Multiply tops, multiply the bottoms. And we get that sine of 2 theta is negative 4 root 21 over 25. Okay? Part B is cos 2 theta. And so there are 3 formulas for cos 2 theta. And all 3 will work perfectly, and you'll get the right answer. If you randomly pick one, all 3 should give you the right answer, unless you make a mistake. Hello? But it's not like they're crazy different. However, there is one that is slightly better than the other 2. Take a look at all 3 formulas and try to decide which one you think is slightly better and why. The one that is, you want to take a guess?
Yeah, would cos 2 theta equals 2 cos squared theta minus 1 be the...
That is the best one. What was your logic?
Because unlike the other 2, this one only includes cos, and we already know exactly what cos equals, and it doesn't have a square root in it.
Yeah, okay. We already knew what cos was. If we did any of the other ones, we'd have to use sine. And we already know what sine is, because we figured it out as well, but we could have made a mistake. A very typical mistake for sine is forgetting the negative, because it's in quadrant 4. So you just give yourself a chance to make a mistake, which you don't want to do. This way, right, the only mistake you can make with this one, which, trust me, people still make this mistake, is copying it down wrong. There's an E error for that. If you can't copy a number right down from one place to another, they give you an E7. You have trouble copying down stuff. Now, order of operations, I would square first. That's going to give me 4 over 25. Then I have 8 over 25. I need a common denominator, so I'll change my 1 to 25 over 25. And I end with negative 17 over 25. Ooh, here's some mental math. If theta was in quadrant 4, what quadrant is 2 theta in? Right? Because they told us that the angle theta, we even drew the picture, was in quadrant 4. What quadrant would 2 theta be in? And answers A and B give you a hint. 3. Why?
Because sine and cos are negative.
Sine of 2 theta and cos of 2 theta are both negative, so 2 theta has to be in quadrant 3. Right? The other thing that some people sometimes do is they say, okay, I'm going to pick an angle in quadrant 4, like 300. I'm going to double it. That would give me 600. Oh, now, where is 600? And then they try to subtract it, ends up being in quadrant 3 as well. But this shows you that it works out to be in quadrant 3 because both of them are negative. questions for practice on this one, just number 9.